Hi, in the previous lecture you learned how to get the LED connected to an ESP32 to blink, and in this lecture I'll show you how to make it fade by using the PWM capability of the ESP32. The Arduino of course can also output PWM, but as you'll see in this lecture, the ESP32 has got several additional capabilities in its hardware that the Arduino, at least the Arduino Uno with the Mega 328P cannot even imagine, as you'll see very soon. So first of all, let's have a quick look at the hardware, and which is very simple. As you can see, it's the same hardware and configuration that we used in the previous lecture with the blinking LED, and then move straight to the software and see what those additional capabilities in software look like. So I've got the LED connected to pin GPIO 13. Let's check out the schematic. Sorry, 33 I should say, so 32. Let's double check that. So I've got it connected to 33, which is okay. It's a little correction on my diagram. In my software, I've got the LED connected to 33, not 32, but either one is okay. As you can see from the map, zoom out a bit, both pins 33 and 32 are PWM capable, so you can choose one or the other. And that's about it. I've got the cathode of the LED connected to one of the ESP32's ground pins. Okay. I'm going to plug it in. And there's the LED fading. Now let's have a look at the sketch that makes this possible. I want to compare the sketch that you're looking at right now, which is the ESP32 version of the fading LED sketch, with that of the Arduino. So in the Arduino, go to Examples, Basics, and Fade. We'll see the example sketch, and here you'll see the analog write function. We pass it the pin that we want, that we have the LED connected to, and then the PWM value, the brightness, which is a value between 0 to 255. And then we can change the value stored in the brightness variable using some kind of loop. In this case, we just do a little addition here inside the loop. So we can, on the fly, change the brightness of the LED like this. And up here we've configured the pin as output. The ESP32 doesn't have access to the same Arduino function, the analog write. Its library provide a new different function called, sorry, not that one, this one here, called LEDC write. And to it we pass a channel number and then the value for the brightness. And this is where the power of the ESP32 when it comes to creating PWM signals comes in, because the channel can be one of many, as we'll see in the documentation. It's one of 16 channels that can be attached to any PWM capable pin. And then the brightness can be any number, configurable again up to 16 bits. This is the resolution. So let's have a look at the documentation to get some more details about what is happening here. So this is the documentation that you can find up here in the data sheet. And if I search for PWM, you'll see examples that describe the PWM functionality to drive motors and to drive LEDs. So let's have a look. A block diagram. It shows us that there is a dedicated hardware module inside the microcontroller for PWMs. This is where the 16 PWM channels are implemented in this block right here. And then continue searching. Okay, so this is a description of the pulse width modulation capability. So we've got dedicated timers for PWM. Each one generates a waveform for one PWM channel. And more interesting is this section here. So the PWM controller, the block that you saw in the block diagram further up, can generate 16 independent channels, which you can attach to any PWM compatible pin. There is an 80 megahertz clock driving those channels. There's a 20-bit timer, and the duty cycle can be up to 16 bits with the 1 millisecond period. So something similar happens with the motors. I think the motor section is somewhere close, but it's about the same. You can see here, I'll go back a bit, any GPIO pin can be used to drive LEDs and attach one of the 16 PWM generators, and the same thing happens with the motor. Any GPIO pin can be used to drive motors, and I've got other lectures that show you how to do that with motors. Okay, now let's have a look at the sketch that I prepared in more detail and walk through it. The source code that shows you how to use the functions such as LED-C write and LED-C setup and LED-C attached, you can find it here. So this is the GitHub repository for Persiv, and specifically for the Arduino ESP32 support source code. And here in this header file, so this is the ESP32 HAL LED-C.h, the header file, you can see the available public functions. So we've got a setup function that accepts a channel, the frequency that we want within the range that is possible, and the resolution. So that's what I do right here. I call this function and set up the channel 0 at 12 kilohertz or 12,000 hertz, and I give it an 8-bit resolution. So the number that I provide for the brightness has to be between 0 and 255. I also need to attach a channel to a physical pin. So I do that using the LED attach pin. Let's make that a bit bigger. So do that in the LED attach pin function. So this function accepts a GPIO and a channel. And that's what I do in the setup function up high. At the beginning of the setup function, I call LED attach pin. I pass it the GPIO that I've connected the LED to, which is 33, and the channel. And this could have been either a 0 or a 1 or a 2, up to 15, because we've got 15 channels available. That information is also here as well as in the data sheet. So I've got the channel attached to the GPIO that I want to use. So at this point, my PWM function as implemented with the LED is ready to go. So let's get into the loop. In the loop, instead of analog write, we'll use LED-C write. That function here is this in the header file. It accepts the channel number and the duty cycle. So the channel number is whatever I set up here in LED-C setup, and then the brightness, which is the duty cycle, has to be within the range of the 8 bits that I selected and I configured this particular channel to use. So it's got to be a number between 0 and 255, and that's it, right here. Now the rest of the content in the loop function is exactly the same as in the traditional Arduino fading LED example. So the result that you see here is for, I think I was playing around with a 4 kilohertz frequency, but let's go for 12 kilohertz and upload the sketch. Double check I've got the right port. Yep, all good. So upload the sketch and see what it looks like. Okay. Let's save it. I need to hold down the boot button to get the sketch to upload. Okay. All right. So this is a 12 kilohertz PWM signal at 8 bits. Another thing that I can do is I can use my oscilloscope to see the PWM value and visualize it, and then I can compare it with the signal, visualized signal of another frequency. Let's make it 6 kilohertz. So let's check it out. I'm going to turn on my oscilloscope and reposition the camera. Alright, so let's connect the probes. I'm going to use a jumper wire to take a signal, PWM signal, into the blue channel and then the ground. I'm just going to press on the auto button and get the oscilloscope to find the signal and display it. And there it is. Just reduce the horizontal scale so we can see it increasing and decreasing. So this is what a PWM signal looks like on the ESP32 at 12 kilohertz and 8 bits. So let's do a little modification. Let's say that we'd like this signal to have a smaller frequency, but the same size of the duty cycle, still 8-bit resolution. What will that look like? And what will the LED fade on and off look like as well? Let's upload that. Press on the boot button. Okay. And you can see it looks wider now. Still the same resolution, so the same step increase in the duty cycle. So you can experiment with that. You can try out different frequencies, different resolutions, see what the effect that has on the LED. And we're going to experiment with this a bit later when we do some experimentation with motors. Awesome. Let's move on to the next lecture now, where we'll play around with an RGB LED.